Hi, Ines.
And you're on.
Okay, thanks very much, Carolyn. My name's Robin Corbett. I'm an astronomer at the University of Maryland, Baltimore County. And Laurence, would you like to introduce yourself?
Yes. Hello, everybody. My name is Laurence Arcadias, and I teach animation at the Maryland Institute College of Art in Baltimore. And I think we have a couple of students with us that we are going to introduce. Also, we have, I think Alea was around. Are you here, Alea, with us?
Yeah, hello.
Yes. And I don't know if Elise is here.
Yes, Alice is here.
Oh, cool. Hi, Elise. Yes. And what about Lena? Are you with us, Lena?
Not yet, no.
And Josh, we also have Josh Olson, our great teaching assistant for the class, but I don't know if he's around. Josh, say hi if you're around.
Yeah. Okay, so welcome to this session on Astro Animation 21. Come and visit an animated universe with us. We're going to be showing you a set of animations related to astronomy. We're going to be talking about the process by which these are being made and the overall project. So as I said, I'm an astrophysicist working at UMBC and NASA Goddard, and Laurence, the co-host here, is at MICA, and she'll tell you a little bit about MICA.
So MICA is an art college located in downtown Baltimore. For the people who don't know the school, we have a growing animation department with a lot of students, and so we teach all kind of different techniques from stop motion to 2D to 3D, and we also have some very fundamental animation courses. And along with that, we also offer a variety of elective project classes, and one being the Astro Animation class that we are teaching in collaboration with scientists located at the NASA Goddard Space Flight Center.
And Goddard is one of NASA's major centers. It's a place where we do research in astrophysics and planetary science and other things, and we also build and operate spacecraft there. We're located in the suburbs of Washington, D.C., which is not too far away from Baltimore, which has facilitated our collaboration together.
So why animation and astronomy? Animation has a power to bring things to life in a unique light. It enables us to tell stories at an emotional and metaphorical level, and it can touch everybody in a universal way. Astrophysics also addresses fundamental questions of the human existence. And here on this image on the right, you can see a piece that was created for the Cheer Sky exhibition. This is a traveling exhibition that was initiated through the SKA telescope with Aboriginal, Australian, and South African artists celebrating stories about the cosmos. And here you can see some images of the work of our students at MICA. So the way they explore some scientific concept is very different from what is done at NASA, where it's all about visualization. So here the students are more inspired by the science to use metaphors and their imagination to express some scientific concept. So even if it's playful and like friendly and whatever you want, it has to come with some kind of some scientific rigor. That's very important. So yeah, that's what I wanted to say about that.
So this work is being done in the context of a class at MICA, where the students are working in tandem with research astrophysicists from NASA So it's taught jointly by an astrophysicist, I myself, and an animator, I, Laurence. And the students get credit for both the science and the art parts of it. And frequently this has led to students carrying on to become interns at NASA during the summer. As well as the usual type of presentations, at least pre-COVID, we try to include more hands-on experiments to try to bring it home to the students that the physics that they learn about through the class, it applies universally, not only to the distant reaches of space, but also equally to the world immediately around them. And often these experiments have led to becoming components of the animations that they're producing.
So during the first week of the class, students hone their animation skills on broad scientific concepts such as gravity or the scale of the universe. And that way it pushes them to connect spontaneously with their personal experience to represent the unrepresentable aspect of the universe.
Then in about the third week, a number of my colleagues come to the class and they present their current research. It can range from black holes, dark matter, exploring moons around the planets in our solar system. The students then split into groups of 2 to 3, and they're randomly assigned the scientific topic they're going to animate, and they're going to be working closely with their scientific mentor during the rest of the semester.
So here you see some images of the very first work of the students. They are going to spend about 2 weeks based on the science that they learned from their mentors to do some graphic research, character design, and they're going to create an animatic or a storyboard that they are going to pitch to the mentor again when they go to visit NASA. And of course, that was pre-COVID. Now it's all online.
Hopefully we'll get back to the physical world again, at least for the visits anyway. But from the previous year, here we see one of the tours. In the top left, you can see Nobel Prize winner John Mather explaining about the James Webb Space Telescope, which is going to be hopefully launched rather soon now.
So during lunchtime, after the tour of the campus, that's when the students are going to pitch their project to their mentors. And usually this session is attended by other scientists who are always very curious to see how MACA students, animation students represent the science. And okay, so back to the classroom. So students have about 8 weeks, it depends of the year, but to work on the production of their animation. So they are really encouraged to use any technique they want as a way to really address their own personal voice. So here on the left, you see a student working on paint on glass, which is kind of unique. In the middle, you have some wax animation done as a strata cut animation where you slice your wax. And on the right, it's like a combination of 2D and 3D images. So again, they can do whatever they want to develop their vision for their project.
Then the students return again to NASA Goddard virtually for the last 2 years because of the pandemic or physically. This has been on Take Our Daughters and Sons to Work Day. So we have quite a large audience, a wide range of ages there. There's a Q&A session, and often there's a couple of suggestions for last minute tweaks to finally finalize the animations. Then the final versions of the films are uploaded to the web. They've also been screened in a whole variety of different places, including scientific conferences, various types of festivals, and great events like Balticon, which we're very happy to be back here again. So now we're going to go on to showing you a set of these animations. Then several of the students will be discussing about that afterwards, and so on. So I'm just going to switch between the different screens here. So please excuse me a moment.
can never find anything that works with my carbonaceous chondrites.
Or my silicate surface.
Or my space-weathered surface. We may all look the same, but we're all unique in our own way because of our shape and our texture. We love all our features, and we hope others can see them too.
This is not playing properly, maybe. Sorry about that. We have some technical difficulties.
I'm sorry.
Exciting when our agent approached us about it.
Quiet on set. Scene 2, take 1. And cut. You're turning too fast, Polymeal.
It's only my first scene, and Lucy's tough. It's hard, you know. She's very meticulous, but overall, she's been great.
I rotate really slowly, so she has been super accommodating.
I think that's what makes this project so special, is that most, if not all of these individuals are new and upcoming models, so this will be such a huge deal for both of them and the public. And that's a wrap, everyone.
Yo. Amigo, you picked up 2 massive readings of gamma radiation. Sending coordinates now. Head on over and gather whatever data you can.
Sure thing. Alright, now let's get to tracking. Ooh! I found them!
Amigo, we're picking up high gamma signatures from your location. Have you located the sources?
Looks like a couple of neutron stars. 2 of them, and they're just standing there, menacingly.
That makes sense. Be sure to keep it good.
I'm gonna get a closer look.
Amigo, you can't.
Yeah, it's cool. I'm cool.
Amigo, come in. Amigo! We detected a massive surge of gamma radiation. And not only that, you appear to have taken heavy damage. But what on earth happened? Amigo?
The neutron stars fused.
What? You're lucky you can still function properly. You aren't built to withstand that much radiation. Yeah, never mind that. You're to return for repairs and a debrief, ASAP. Do you understand, amigo? Amigo!
This is carbon. and this is hydrogen. The two of them form the basic foundations of a lot of molecules, including polycyclic aromatic hydrocarbons, which is a mouthful, so let me explain. In order to form polycyclic aromatic hydrocarbons, a group of carbon atoms link together to form a two-dimensional chain-link structure. And attached to the edges of this molecule are hydrogen atoms. When this polycyclic aromatic hydrocarbon, or PAH, is hit with radiation from a star, the atoms come alive with energy. When the energy reaches the hydrogen atoms, they begin to shed infrared light. This is called hydrogen out-of-plane bending, but there are different ways PAH molecules can shed infrared light. As the light travels, the universe is expanding, and so the infrared light becomes even redder. By measuring this redshift, we can determine the distance between our galaxy and galaxies further away. A little bit of dust and light means a lot of new information for us about our universe.
So Robin, you were supposed to say a few words about the science.
Yeah, right. So originally planned to say a few words about the science before we'll do it now. So see, yeah, I got out of sequence, I'm afraid. So yeah, so we saw quite a range of different types of animations, some quite surreal. I say, but they are still rooted in the science which has been done. So the first one we saw was talking about Trojan asteroids, and there's a mission called Lucy, which is going to be launched soon to explore these asteroids, which are in a special orbit with Jupiter, and they have a whole variety of textures and speeds with which they rotate, which was where that comes from. The Amigo mission is a new gamma-ray space telescope which is being developed, and one of the exciting things it's going to study in more depth are merging neutron stars, which we know already produce bursts of gamma radiation, but fairly recently we discovered that they also produce gravitational waves as predicted by Einstein. Jupiter's moon Europa is a fascinating place. It's got a crust of ice, but underneath we believe there is a vast ocean, and potentially there could be the conditions for life there. We have liquid water and energy, and the scientists working on this suggested the animators that since we don't know what it'd be like, they should just go as crazy as they feel like it. For black holes, there are two main types. There are ones which are relatively small, although they're still about 10 times the mass of the sun. And there are others which are much more massive, which are found at the heart of quasars. And so that's why the animation was referring in an allegorical way to having different sizes of black holes. These can produce enormous amounts of energy. The one on PAH molecules is a complex type of molecule found in space. And by observing them, we can learn a lot about the conditions around stars and spaces between stars and galaxies. Then the last one was about a system called TRAPPIST-1. This is an amazing planetary system which contains multiple stars around this M dwarf star. And these are all located in many of these are located in the so-called habitable zone where liquid water could exist. And so this could be a place where life could exist on multiple planets potentially within that. So now we're going to go on to the making of these, and I'm going to invite Alea to talk about this. And if you tell me when you want to go to the next slide, I'll click for you.
Yeah, Robin, your screen is it's not the it's not the right setup. Just to let you know, because we see all the yes. Now it's working.
All right, so hello, my name's Alea Nobeza, and I was one of the people who worked on the Trojans film in collaboration with Simone Marchi and Kathy Olkin. And so how it started, our scientists first talked to me and my partner, Gianna, about asteroids, what they are, their shapes, their compositions, all that stuff. And so next slide, please. And so this led to them talking to us about the Lucy mission and their part in it, in which Robin briefly explained NASA was planning on sending out a spacecraft to look at these Trojan asteroids, which are like two groups of asteroids located around Jupiter. And during our discussion with them, they brought up the point of that they want to emphasize on the surface of the asteroids in the animation. And so Gianna brought out of a brilliant idea of making it like a beauty commercial. And so we would get the opportunity to see these textures of the asteroids up close and personal. And we took off with that idea, and I brought up the idea of combining 2D animation with 3D animation. And so that's what we have in our final film. Next slide. Next slide. So in our process, I did most of the 2D parts, so like the background and working with the character Lucy. And for all of our characters, we both knew we wanted to take it in a literal direction rather than it being like representative. And since we would be focusing on the texture of the asteroids, it kind of made sense to go with that route. And so we decided to do like the 2D faces and limbs on them and keeping it like a lighthearted and like a fun tone. And we also took inspiration from like the character designs from Dumb Ways to Die, if you're familiar with that. And so with Lucy's design is like very different from what we originally had it, which is what's pictured up here. And this is because I saw it in an animated video on NASA's website about the Lucy mission. They also had, Lucy was like built like differently. And so I thought it would be a neat idea to keep that consistency in our animation. And so that's why it's a little bit more complex than like the rectangular head that you see there. Next slide. Next slide, please.
Oh, are you seeing that now?
I see the asteroids, but it's like in the wide view. Go back a bit.
Oh, sorry. Is that the right view or not?
Go to the asteroid slide, please.
Okay. I clicked on the chat button in Zoom and it took me out of. So, sorry, I'm going to just stop and restart again. I apologize for that.
Okay.
I should not. I saw the messages in the chat and I was looking at that. It's a mistake. My previous mistake. Okay. Are we on the right screen?
No.
Oh,
I mean,
no.
on a wide screen maybe, but not on a wide view. So.
Okay.
Okay. With the asteroids, Gianna was the one who handled all the 3D elements. So like replicating the asteroids from like the imagined image that Simone gave us, and then also blocking out where they would be in the film. And I'm really grateful for that. And so by the end, we kind of worked together on who would do the faces and who would do the limbs for both of the parts. Next slide.
Sorry, it's giving me a message about screen sharing is paused. So you're not seeing the slides advancing. I've just start again.
Maybe you can show it on the regular view. Maybe it's not too bad if we see the underneath, you know. Yeah, maybe you want to stay on this view if that does not work.
Okay.
On that setup, I mean. Although that's going to be hard to see.
Okay, I could try again, switching the displays.
Okay, so with the storyboard, Gianna was the one who made the storyboard for the commercial itself, while I worked on the behind the scenes stuff and the interviews. And we just kind of collaborated back and forth. I'm talking about which ones would work best and which scenes to like take out and things of that nature. And when we like look at these behind the scenes stuff for like commercials, you'd usually see like interviews. So we thought it would be a fun idea to have like interviews with the asteroids and with Lucy herself talking about the mission, and like the asteroids talking about working with Lucy in this case. And we decided to include like some fun tidbits of what we already know about some of these asteroids. So we took like 4 asteroids, for example, and just thought of what would be best for the interview section. Next.
Sorry, again, the same problem again about.
So for like the next 2 slides, it's just our animating process. So on the left, Gianna was the one who animated that asteroid collision in front of a green screen, and then putting the stars in the background, and then adding like the facial features and like the collision effects and particles. On the right, I took a screenshot of the last frame of like the advertisement, and then made some like little motions for the hand movements for the asteroids, and then add like the overlay for the camera and like working on Lucy on it, and then that's what we have. Next. More of the progress. The left is the progress on like one of the segments for the Lucy interview, and kind of getting an idea of like how to pose her and like what she does when she's talking. So when she's like getting like really excited, she kind of just like opened up like the panels acting as her like arms. And on the right is what Gianna worked on. And because it's the behind the scenes part, we didn't see it be necessary to add the stars in the background. So we just left it as the green screen. Gianna created that clapper animation and then animated the turn. And essentially this is what we did for like the rest of the film. And so, yeah, that's pretty much it. Thank you for your time.
Thank you very much.
Yeah, thank you, Elia. That was great. Sorry for the little technical issues, but you are doing great. So thank you.
Okay, hand across now to Ellis, please, for Inside Europa.
Okay, hello everybody. So Inside Europa was done by myself and also Kofo. She's not here right now, but yeah. Next slide. So Inside Europa takes place on Europa, about a bounty hunter that sees a reward on a wanted poster and decides to go for it, but turns out the monster is much bigger than she originally thought, and then she ends up like trying to escape rather than secure the money. Next slide. So it's basically about Jupiter's moon, Europa, Jupiter's moon, and how it's significant because under the very thick layer of ice, there's a large body of water that's supposedly has life there, since on Earth, where there's water, there's life. So it serves to reason that that would be the same case for Europa, especially since it has so much more water than Earth. Yeah, and we wanted to explore a lot of the environment of Europa besides just like the creatures, even though like the creatures is the first thing you think of. It's like, oh my gosh, no one really knows what lives there, and we can definitely go crazy with it. But first problem we faced really was, how do we get under the ice? It's so many miles, like it's thick. Like our film didn't really show it, but it is deep. And that was definitely a huge challenge, to even find a way under there to see the creatures. Anyhow, I'll get more into that later, but artistic intentions, merged some 3D and 2D. Yeah. Next slide, please. This is our mood board. Kofo was in charge of the character designs and concepts, and this is what inspired her for a lot of the creatures, especially the background with the parallax view of when like the person finally gets underwater and you see that like all those details. I think she did a marvelous job, definitely added a bit more like just so much more energy and vibrations with the amount of detail she put into it, if that makes any sense. Yeah, next slide, please. I was in charge of like texturing, and I did the storyboards too, and some, yeah. But mood boards, this was what I was going for with water. Did it come across? I'll leave that up to you. Next slide. Okay, so that was like, these were all like pre-production. So this was the character example. Kofo designed the character. She eventually ended up changing the color scheme. This was environment examples I had originally set up. I think they ended up in the film too. Yeah, they did. Originally, I was gonna do the ice completely in 3D. That is why there's like a 3D render of ice there. But then I realized my limitations, and you know what? It was hard to see it go, but it had to go. Anyhow, and creature examples. This is one of the first drawings of the creatures. It didn't end up in the film. I do not know why. Kofo is not here to answer. Next slide. Oh, okay. So character and story. As I mentioned before, Kofo was in charge of the creature designs. And since like there is suspected life on Europa, there isn't any observational like references we could take to create the visuals. So she really could just like pull anything out of her imagination. And she really did. She went crazy with it. Love her for it. It definitely made the film so trippy. But yeah, and the storyboard. So this is one of the final panels for the full storyboard. I should have probably included the whole storyboard, but here you see the final one with like the monster about to, you know, eat the ship, but the ship escapes. I ended up just using the same file for the storyboard to create the final animation for time purposes. Yes, shortcuts all around. But yeah, it was a fun project. Next slide. Background and environment. So like, as I was mentioning earlier, a huge draw, at least for me, was the ice itself and the environment itself. So a lot of questions that we asked our scientist Connor was like, since we didn't know specific, like a lot of solid specifics about the creatures, I tend to lean heavily towards questions about the environment itself, because at least like some of those could be could have some like observable like information given back. So like when I mentioned, I had asked about if there would be, I don't know what it's called, but you know when like smoke rises because something's hot, but like sometimes smoke sinks because it's just like super, super cold. I asked him if there would be something like that for Europa, like some kind of like kind of icy kind of fog type thing going. Ooh, I am just rambling. But and then it led into stuff about water plumes and just how there could be like how any water that's exposed immediately freezes. We wanted to put that in there, but time constraints happened. And then Kofo just did this masterpiece of monsters. Yes. Anyway, next slide. Oh, and this is our old animatic, but it'll take way too long to get through. So I think that's it, right?
Yeah.
Yep. Thanks for watching.
Okay.
Thank you, Elina. That was great.
Okay. And I believe, so if you're interested in and would like to try your own animation here, Josh is going to talk about an idea of a possible thing, if you'd like to.
Yeah, so we have an activity set up and a bunch of a few steps and information, background information about black hole and spaghettification. But the activity is from a free app called FlipperClip, and you can download it on your phone and yeah, your smartphone or a tablet or something. And basically, it's all drawn and all done with your finger. But if you have like a stylus, that would work too. Is there another?
Yeah. Oh, by the way, so just very quickly, so this is to talk about what we call spaghettification when you're near a black hole. So if you were to fall into a black hole, you would be stretched because of the difference of gravity on the top of your head and the bottom of your feet and squeezed together. So basically you get turned into spaghetti as you fall down into a black hole in quite a dramatic way. So the suggestion is to do an animation related to that, and I think there is even like a Wikipedia page about spaghettification black holes if you want to check on the science behind this. But this is one thing which could be fun to animate. There's the two pages we have here, I think.
Yeah, so that was
back to you, Josh.
Yeah, the spaghettification was like the concept of turning it into an animation. And this is just a couple of steps and tools that could help you out when you first log into the app, and just some things that you could kind of find out as you go. But this will help you. This will give you like a head start as you're looking through it. And that's a little example of a GIF that you could create. You could create either a GIF or a regular animation with sound when you export your animation in the app. And then you could if interested and you complete it, you could send it to us at are they gonna have people gonna have access to this?
Yes, so if you go to the final image, Robin, I did put the yes, so people can take a photo of that with their phone. They can scan it, and then it's going to take you to the page with all the information of how to send us the animation. And if we like it, we let you know, and then we may, use it in some presentation of the work. So that could be really fun.
Okay, well, yep.
Yes, if someone can put the link in the chat, yes, yes, I'm going to try. I should have been more ready. I know I have it somewhere. I try to find it. Let's see. Yeah, I wanted to put the file. The file did not work, but the URL. So So meanwhile, if you have any questions for us while I try very fast to find the
Okay,
link.
I think we should, I'll go to the last slide, if that's okay with you, Laurence.
Yes, yes, of course.
Yeah, so we're going to be very happy to take questions and so on, and say thank you very much. We do have this website, astroanimation.org, where films from this year are going to be uploaded, and the ones from last year are uploaded. So there's about 50 of them there. They're available free for non-commercial use. So if you find that they would work for some educational or festival or whatever purpose, that they're freely available for you. They're under a Creative Commons license. And I'm not sure if it's there at the moment. Maybe on the astroanimation.org website, we can also have the instructions there for downloading the software for doing your animations and a place to upload it. It may not be there at the moment, but we could certainly put a link on that page, because we have a variety of other things in there.
And the link is on the panel now. It's in the chat. I just found it in the chat.
Okay, great, thanks. So I'm going to stop sharing, and we'll be very happy to take any questions.
But thank you for our presenters. You guys were great. It's exciting to have you as students and as speakers. And thank you, Josh, also for the demonstration. Thank you, Anne, for applauding.
So we have a then if we have any Q&A questions, or do we have chats as well?
Okay, so yeah, I don't think we have more questions from the chat. So, but again, it was great. It was a pleasure to show those animations and share it with the audience. And I hope you'll have a wonderful Balticon, or whatever is left over from the weekend.
Yeah. Okay, so I guess we wrap up. Oh, so is there something in the Q&As there? Okay.
Again for today. So we can, okay, so thank you, Ed. Yes, there's a few, we can.
So there's a question from Anne Brink, says, for all the students, what was the best part of doing this particular project?
I think for me was finalizing like the final result of it, because I know we were both kind of like stressing out over what should be done, because we all have our own things to work on, because we're still in classes, while also we're in like a Zoom class, so it's kind of taking like a mental toll on us. But it was like really nice to see what came out of it at the end of the day.
Cool.
For me, it was the opposite. I liked the pre-production more, since it was all the cool ideas, all the possibilities still up in the air to be grabbed. Yeah, me and Kofo, we went through like a lot of iterations for the story, because we both came at it from two completely different viewpoints, and we had to merge it into one semblance of a story. Anyway.
Okay. Oh, thank you, everybody. Yeah.
So thanks very much for everybody for coming along, and thanks very much for all the animators and the other scientists at NASA who participated in this. It's great that so many people kept this going, so many great products continue to come out year after year. I say that as something that I'm not doing the animation, so I feel free to compliment the people who are doing this.
It has been a great class, I have to say, and it's very exciting to see how it evolves, through the years. So thank you, everybody, for being with us on that. So I don't know for how much more time. Okay.
Okay. Bye.
Bye.
Goodbye.
Goodbye. Thank you. You are great, Elise. Thank you so much. You have so much
Yeah.
energy and enthusiasm when you talk. It was beautiful. Thank
Oh,
you.
wow. But too much energy, but can't wait to see you guys next year. I mean, this
I
fall
know.
in person.